of change. What is instant rate of change? So remember we looked at like speed and velocity and being able to find those rates of change at particular moments. Okay? We're now going to be looking at antiderivatives, okay, or what is also called integrals this semester. And basically it's going to help us answer the question of how do we find area of non-geometric shapes. Meaning, like, if I have a curvy shape, right, that's just some big wave, how do I find the area that is created by that shape? Or the area between two curvy shapes? So how do we find area when we're not dealing with straight lines or circles? Okay. But first, we have to kind of work our way up to that by figuring out what an antiderivative is. What does the prefix anti mean? Opposite. So we're talking about the opposite of a derivative. Or basically going backwards. So let's just go back to find the derivative of f of x. So what is the derivative of f of x? Alright, what is the derivative of g of x? Or the derivative of h of x? Yeah. So now, if I wanted to go the opposite direction, so let's say I'm starting with the derivative, okay? What rule would we use? So basically, the opposite of our power rule. How do I get back to what we started with? Add 1 to the what? What's that?
Come on, Cole.
The exponent. Yes, thank you. We're going to add 1 to our exponent, and then we divide by that instead of multiplying. Okay? And that is our integration power rule. So the way that we could say that is if, we'll use f, so f prime of x equals x to the n. Okay? So again, I'm going backwards. I'm trying to figure out what my original f of x is. Okay, so we said we're going to take our x, we're going to add 1 to our exponent, and then we're going to divide by whatever that new exponent is. Agreed? Is that the only thing that happens there, though? Do you have anything else that's happening on a couple of those? Oh, we have constants. Yeah? How do we know what the constant is?
It'll be given to us.
Not necessarily. It will be given to you. Now, sometimes they could give you information that will let you find it, okay? But when could there be a constant at the end? If I'm just going backwards. Do we know if this is the only information that's given to us? When that constant could occur?
No.
No. So, I'm going to introduce you to my friend. Okay? So, his name is Carl. He's Carl the Constant. And he's like that needy friend of yours that suffers from real bad FOMO. Okay? So, he invites himself to all of the parties. He invites himself to all of the dates. Okay? He tags along with everything that's okay? So, anytime that we take an antiderivative, Carl has to show up. Okay, we have to put in a plus c, because there could potentially be a constant there. What?
You said Carl Harris?
Sure. Alright, so let us look at an antiderivative. So, in other words, f of x, it is the antiderivative of f prime of x, okay? capital F. I'm not as big a fan of the capital F because it can be hard to tell the difference between the two. However, you might see that written sometimes. Now, just like our little tick mark or our dy dx means derivative, okay, we have a symbol that means antiderivative, and it is the integral symbol. It's kind of like a big S. So we have the integral of f prime of x dx, or it can also be written as the integral of capital F of x dx equals little f of x, and again, remember that we have to add our plus c. Now, basically that dx that's there is just telling you what you are taking the antiderivative with respect to. Just like we have a dy dx, and that bottom d whatever tells you what you're taking the derivative with respect to, the dx just tells you what you're taking the antiderivative with respect to. So far, so good? Yeah. So, antiderivatives allow us to go backwards or to undo derivatives. So they actually allow us to be able to now solve differential equations. Let's break that apart. What does differential mean for us?
You take the derivative.
Yeah, it's a derivative. I have a derivative, and where do I have a derivative? In an equation. Yes? So just like if I have a square root, we have to square both sides, alright, to solve for it. If I have a derivative, I have to take the integral, or the antiderivative, of both sides in order to solve for it. Now, the only catch is that we cannot integrate it with the dy dx there. So what we have to do is first separate the dy and dx to opposite sides. Then, once we've done that, we can integrate. And don't forget the plus c. Now, a little bit later on this week, we are going to look at when they give us some extra information on how we solve for that plus c. But in general, plus c's just mean that I have a general solution instead of a particular solution. So, what do we say our first step is? Okay, where is our dx right now? On the left side, and it's on the denominator. So how would I undo or get rid of or move to the other side something that is in my denominator? Multiply. So now on the left-hand side, we're just left with dy, and then on the right-hand side, we have 3x squared dx. But again, remember that the stuff on the previous page that I was taking the integral of had a dx on it, okay? And the only thing that's different about our dy is instead of taking the antiderivative with respect to x, I'm going to take the antiderivative with respect to y, which is why we want them on opposite sides, because I can't take the antiderivative with respect to two different things. Does that make sense? So that's why we have to separate them out. Now, once they are separated out, I can go ahead and integrate both sides. Integrals are an operation, so as long as I do it to both sides, we're okay. So if this is just a 1, and I'm taking the antiderivative, okay, what would the antiderivative of 1 be? It would be x, or in this case, because we're taking it with respect to dy, it's just going to be a y. Are we okay with that? Okay, and then using our anti-power rule, basically, that we talked about on the previous page, what do I want to do with my exponent on the right-hand side? Add 1, so we get to the third power, and then we're going to divide by 3. And what did we say we can't forget? Plus c. Now, technically, okay, when I took the antiderivative of the left-hand side, alright, we should have added a plus c over here, okay? However, if I have a constant on this side and a constant on that side, and I were to move the y constant over, would some number minus another number still be a constant?
Yeah.
Yeah, so instead of writing like C1 and C2, we just let one of the sides get a C, and we say that constant basically like shoots up all of the constants for that equation. They're lazy and we don't want to write 300 constants, okay? Now, let's simplify that a little bit. 3 divided by 3 gives us what? 1. So we just end up with x cubed plus c. So that's what we call the general solution. Alright, it's not particular because I still have that plus c there. Questions on that? Alright. Let's look at a few more antiderivative rules. So, this tells us to find the original function f given this derivative. So, on our first one, what is our understood exponent there? 1. So, if I add 1 to that, what do we get? 2. And then if I divide by 2, what happens? I should get a 1, so I should end up with x squared. And then what do we have to add? Plus c. Similar, my next one, I still have a 1 as my exponent. So I add 1, I get 2. But now when I divide by 2, what do we have? 1/2. And again, adding our plus c. Now, are these two c's necessarily the same number? No. Okay, you could have multiple c's for the same equation depending upon the other information that they give you. So just because they're all c's does not mean that they're the same number. Okay. Now, on our next one, if we add 1, what do we get for our exponent? And then divide. So we have 1/3 x cubed plus c. Now, what's different about the next one? It's a fraction. Oh no! What do we do? Rewrite it. How do I rewrite things with fractions? Yeah, so just like we did when we took the derivative, I'm going to rewrite this using a negative exponent. Okay, and I can take the antiderivative. The only thing we have to be careful about is now we're adding. Okay, so if I add 1 to a -2, what do we get? -1. So I would add -1 divided by 1 times x to the negative first. Yes? Which is the same thing as -1 divided by x. Again, plus c. So what would we rewrite e as? X to the -3rd. Yes, there we go. So now this time when we add 1, what do we get? And then again, we have to divide, so we're going to get a -1/2 x to the -2nd, which is also a -2x squared. Let's see. We're okay with that. Now, the last one, can I use my anti-power rule on it? No, not on the last one. Because what do we have? Do we have a power on that one? No, what do we have? Power rule, yeah. We can't use a basic rule. It's just not going to be a power rule this time. Okay? So we kind of have to think backwards. Okay? The derivative of what gives us cosine? Sine. So that means that my antiderivative of cosine is sine. Now, it's not on here, but let's go ahead and look at it. If I had the antiderivative or the integral of sine, what would I get there? It's going to be a negative cosine. Okay? Because again, the derivative of just cosine is a negative sign. So to negate the negative, I have to put an extra negative there. Yes? Alright, I'll okay with that. Alright, you're back to the rolling. Now we're just going to combine those, just like with our derivative rules. I can add and subtract those. With our integrals, I can also add and subtract those. Okay, so I can combine the rules together. So on our first one, what are we going to get when I add 1 to my exponent? Okay, and then I'm going to divide. So we get 3/5 x to the 5th. Yes? Now, what do I need to do to the second one? Okay, so 1 over x is what? Okay, so if I take the integral of x to the negative first, what would I do? Which gives me?
0.
Yeah, but then what do I have to do? Divide by that? Can I do that? No, it's a big no-no. So I cannot use my power rule here. Well, let's see. Do we know the function that when I take the derivative of it, I get 1 over x? Yeah, natural log of x. So, the integral of 1 over x is going to be the natural log of x with a little exception. So just like, remember that like when I am the one that takes the square root of both sides, what do we have to do to an equation? Plus or minus, right? We have to account for the domain. The same thing is true here. Whenever we are going backwards and we end up with a natural log of x, okay, what is special or what are we not allowed to have with our natural log of x? Negative. So what we have to do to account for that is we put absolute values around our x. Because technically, this could be a negative number that we're plugging in there, and that would make it be bad. So we just go ahead and say like, I'm just going to make sure that doesn't happen, and put absolute values around it. So then what are we going to have here? Plus natural log of the absolute value of x. Okay, what about our next one? What can we rewrite a square root as?
2x.
Okay. So then when I take the integral of that, still adding 1. So what is 1/2 plus 1? Okay, and then how do I undo, or how do I divide by 3 over 2? Yeah, so we get 2 times 2/3 x to the 3/2. What is 2 times 2/3? 4/3 x to the 3/2. And again, what do we have to add? Plus c. Yes. So as of right now, we know our basic power rules and a couple of our like basic, just kind of like function rules. All right. Other than that, we don't know anything else. We're gonna learn a little bit more of some of our integral rules on like how to undo a chain rule. That's about it, okay? We're not going to learn how to integrate things that would have required the quotient rule, and we're not going to learn how to integrate things that require the product rule. So if I have things that have quotients or products, we have to get rid of those quotients or products some way, okay? So that we can use one of our basic rules. So, on this one, what do we have?
Fraction.
We have a fraction. Alright, like I just said, we do not have a rule so far that lets us do something with a fraction. So we need to get rid of the fraction. How might I do that? Is there a way that we can rewrite any part of that? We could, but again, I'm trying rid of the fraction, right? So even if I multiply the square roots of the top and the bottom, I would still have an x on the bottom, right? Was there another way that we could rewrite it?
Do x plus 1 times x to the negative 1 half.
Sure. Okay, but now I still have multiplication, so I need to get rid of that. So what can I do there? Yeah, so when I have things that have the same base, okay, and I am multiplying them, what do I do with the exponents? Add them. So what is 1 plus negative 1 half? 1 half. And then I just have a 1 here, so this becomes x to the negative 1 half. Yes? We also could have left it as a fraction and still written this as x to the 1 half, and then I would have just been subtracting my exponents instead, so you end up with the same thing. Yes? But now, is this, my new addition, something that we can apply our power rule to? Yeah. Okay, so if I add 1 to 1 half, what do we get? 3 halves, and we divide, we get 2/3 x to the 3 halves, plus, if I add 1 to negative 1 half, what do we get? Okay, and then if I divide by that, we get 2. And again, we have to add our plus c.
Wait, so how did you go from the, how did you like distribute it?
Distribute what?
Like the.
Yeah.
Yeah.
Like, are you trying to see how I got this first one?
Yeah.
You understand how this times 1 is that, right?
Yeah.
Okay. So this is an understood 1 times x to the negative 1 half. Yes?
Yeah.
That's what we do.
Yeah.
If I have the same base, then we just add our exponents. So this becomes 1 plus a negative 1 half. Right? Which what I was saying is the same thing. If I had left this as x to the 1 half on bottom, I would have been subtracting my exponents, which is the same as 1 minus 1 half. So I still get x to the 1 half. Does that make sense? Yeah. So some of the times we're going to use our power rule. Some of the time we might have to use some of our trade rules. Yay, trade rules. We like those, don't we? Aw, they're so much fun. Alright, so what might it be helpful to do here? Again, we don't have a rule that allows us to do division, so we got to do something to it.
Make it all sign.
By what?
Aggregate.
Sure. And what would we get?
Sign minus 2.
Not quite. Because it's a sine, it's a cosine squared, right?
Yes. Squared x.
Almost.
Negative sine squared x. Wait, yeah.
It's sine squared of x plus 1.
No. No. Flip your negative.
Negative sine squared x plus 1.
Yeah, or in other words, 1 minus sine squared of x. Yeah. We're okay with that. Okay. Then what do I want to do? We still need to get rid of our fraction, yeah? Alright. That top almost looks like our bottom, yeah? But it only has a first degree. Is there a way that I can split something apart that has a second degree into something that has a first degree?
Yeah, make it sine of x and sine of x.
Not quite. Huh? Yeah, so I want to factor it, yes? So to go notice I have a 1 and I have a sine squared. Both of those are perfect squares, so we can factor that using our difference of squares formula. So this would become 1 minus sine of x times 1 plus sine of x. Well, notice, okay, I have a 1 plus sine of x on the top and the bottom, yeah? So what do we want to do there?
Reduce.
Sure. What do we get?
1/3 minus dx.
Okay. What do I still have?
Fraction.
A fraction. We have a rule that allows us to do a fraction. No. So what might we need to do?
Right.
How would I rewrite that? As of right now, we also don't have a way to do something that has something on the outside and something on the inside. So is there a different way that we could have rewritten that? Yes? Not quite. So, I have two things here on top, yeah? If I have one thing on bottom, can I separate this into two separate fractions? Yeah. We're okay with that. Yeah? Alright. Now, we can separate it into two cosines, like someone was saying earlier. We're all okay with that. Now, what is sine divided by cosine? Tangent. And what is 1 divided by cosine? Secant. And if I have 1 divided by cosine squared, I'm going to get a secant squared. Did I get rid of my fractions? Yeah. So now we need to think, do I have a function that when I take the derivative, I get this first one, tangent secant? Secant, agree. Do I have something that when I take the derivative, I get secant squared? Tangent. So that in here. Yay! Questions on that one? Alright, we have one last one. So what do we have going on here? Multiplication. What did I say? So, and again, right now I don't have a way to take the integral of multiplication, so what could I do to get rid of the multiplication? Yeah, like multiply it all out. So t times t gives us t squared. T times 1 gives us t. Negative 2 times t is negative 2t, right? So the negative 2t plus t would give us just a negative t. And then I have a negative 2. We're all okay with that. Now, let's also remind ourselves of some derivative rules with our exponentials. So what is the derivative of e to the x? E to the x. Times, yeah, if I have something besides just an x there, then yes, I have to use my general, okay? Which also means that it's nice because my antiderivative of e to the x is also just e to the x. So when e to the x's come in, don't freak out. They're actually pretty straightforward to deal with, okay? Now, however, we do need to think about, do we remember our other base rule? ln of, so in this case our a is 5 times, no, just 5 to the x power. So it's still just the thing to the x power, right? So in this case 5 to the x. But because it has a different base, we have to multiply by an actual log of 5. Now, the only thing is, okay, if I was trying to take the antiderivative of just the 5 to the x, what do we have an extra thing over here of? We have an extra what? Natural log of 5, right? So how would I get rid of a natural log of 5? If this is multiplication, I would divide, right? So in other words, the derivative of 1 divided by the natural log of 5 times 5 to the x would just give me 5 to the x. Yes? So when I go backwards, we are going to have to divide by a natural log this time instead. So, on our first one, I add 1 to my exponent, and what do we get? Okay, so then I'm going to divide by 3. So I get 1/3 t cubed. What do we get on our second one? Yep, it is going to be negative. Okay, and then what about our minus 2? T, yeah, minus 2t. And then we just found that this is going to be 1 divided by the natural log of 5, 5 to the x. We do have to add, I did not put it here.
Okay, so how come we turn it into 1 over L?
So notice that we're trying to go backwards, right? So I'm trying to say, okay, the derivative of what gives me 5 to the x? Yes? Well, the derivative of 5 to the x gives me natural log 5 to the x, but I don't have a natural log 5 to the x here, right? So I had to say, okay, well, if I wanted to move that over, instead, this is an equation, right? I could divide by a natural log of 5, right? Which is the same thing as 1 divided by the natural log of 5. Yes?
I kind of get it.
Okay, so let's see. Alright, so do you agree that if I take the derivative of 5 to the x, I get this?
Yeah.
Yes? Alright. So now, all of these equations, right, are antiderivatives. Which means that if I want to go backwards to like check my work, I should be able to take the derivative of this and end up with what I started with. Do we agree? Okay, so if I take the derivative of 1 divided by the natural log of 5 to the x, okay, now, what is, again, the derivative of just the 5 to the x part? Natural log of 5 times 5 to the x. But now I also have this natural log of 5 out front, which is what we want, because we want, again, we want that to go away. Because I just want to end up with these should be t's, but I just want to end up with a 5 to the t. I don't want to have an extra natural log of 5 there. So in order to like undo or to account for there being that there, we had to divide by it, so that way if I were to take the derivative, now we would undo each other. Does that make more sense?
Yep.
Okay.